Welcome! Consider you want to redecorate your living room. To place your television, you want to be sure you can watch it properly. One of the things you want to look at is that the angle of the line from your eyes to the left, respectively right side of the television remains large enough. Basically, this angle determines how big the television is in your field of view. But how can you calculate this angle? Using the angle formula from this video, this becomes easy. The angle formula says that the cosine of the angle between two vectors equals their dot product over the product of their lengths. You already know that a straight angle corresponds to a zero dot product, which in the formula gives the cosine of the angle equals 0. So the angle is indeed 90 degrees. To prove the formula, we will use the definition of the cosine as the quotient of the length of the adjacent side over the length of the hypotenuse in a right angled triangle. Our argument only works for acute angles, so for obtuse angles you need to modify it a bit. Now, consider two vectors. To use the definition of the cosine, we need to somehow find a right angled triangle which contains the angle between V and W. Let us create it by drawing the line perpendicular to the vector V from W. This now gives a right angled triangle. The point P on the line through V is the endpoint of the so-called orthogonal projection of W onto V. Orthogonal is a fancy word from ancient Greek meaning perpendicular. To determine the cosine, we need the lengths of OP and of W, so we need to know which point P is. Let us look at what properties P, or the projection vector OP, has. First of all, the vector points in the same direction as V, so OP is a multiple of V. And moreover, PW is perpendicular to V, which means that the dot product of PW with V equals 0. Now the vector PW equals W minus OP, so we obtain the equation W minus CV dot product V equals 0. This expands to W dot V minus C times V dot V equals 0. Bringing the C times V dot V to the other side, we find that W dot V equals C times V dot V. So we can solve for C and obtain that the projection of W onto V equals the vector P equals W dot V over V dot V times V. At first sight, this formula is a bit hard to understand. So let us do an example. Consider the vectors V equals 1, 1 and W equals 3, 1. Then the projection of W onto V equals the dot product of V and W, which is 3 plus 1 equals 4, divided by the dot product of V with itself equals 1 plus 1 equals 2, times V, so 2 times V, which is the vector 2, 2. Thus the quotient in front of V is indeed the ratio of two numbers. Recall that you cannot divide vectors. And indeed, W minus P is the vector 1 minus 1 is perpendicular to V, which you can check by calculating the dot product of V with 1 minus 1 and observing it becomes 0. Now we know the formula of a projection, we can continue with our goal of obtaining the angle formula. Recall we have two vectors V and W and draw a right angled triangle by projecting W onto V. The cosine of the angle between V and W then equals the length of the adjacent side, that is the length of the vector P, divided by the length of the hypotenuse, the length of W. Now, we plug in the formula for P, and as multiplying a vector by a scalar multiplies the length by the scalar, we can take the scalar V dot W over V dot V outside the norm. If we finally realize that v dot v equals the length of v squared, we obtain the desired formula. The cosine of the angle between two vectors equals their dot product divided by the product of their norms. Let us go back to the television. From the map, you can see that the vectors are v equals minus 1.5, 1.5, and w equals minus 0.5, 1.5. Thus, we can evaluate the cosine of the angle as the dot product of v and w equals 3, divided by the product of the norms, which simplifies to 2/5 times square root 5. Taking the inverse cosine, we see that alpha equals roughly 26.6 degrees. Good luck with the exercises.